Hello friends, today we will see the topic swap space management presented by Ashutosh Kawalkar and Ajay Singh Rajendrakar. So in this video of swap space management, we will cover the following topics: introduction, why swap space, what is swap space management, examples, and some questions. So introduction. A swap space is a space on a secondary memory that is on hard disk used as a virtual memory in order to extend the computer's real memory, that is RAM. Having a swap file allows your computer operating system to pretend that you have more RAM than actually you do. Why swap space? As the amount of physical memory, that is RAM, is limited, and if this RAM gets full by the processes and we need to perform some new task or new programs in the system, there is no space for the new programs. As a result, your system may get slow or collapse. So here comes in the picture swap space. And also the reason behind using swap space is to make RAM more efficient as compared to the present state. What is swap space? Swap space is a part of secondary memory we use as a virtual memory, that is extension to the RAM. Its main use is to load the inactive pages from the RAM to the virtual memory or vice versa, in order to make the full use of RAM or proper use of the RAM. Swap space management. Swap space management is the technique to efficiently use the swap space. Swap space is a virtual memory, as we seen already. Uses the disk space as an extension of main memory. The main goal for the design and implementation of swap space is to provide best throughput for the virtual memory system. Swap space generally holds the process image, that is the process which are not in current use or which are just stored in the RAM, that are loaded in the swap space. Swaps uses the paging technique, that it stores the pages that have been pushed out of the memory. Swap space can be carved out of the normal file system or in a separate disk. That is, there are two ways to create the swap space. Either we can create it in our normal file system, that is file explorer, or we can create it at the time of disk partition. To access the directory structure and the disk allocation data structure, swap space takes more time than RAM, as it is a part of secondary memory, and secondary memory is too slow than the primary memory, that is RAM. The user gets problem, that is the speed is slow when we load the pages from swap space to the RAM.
As we see, hello friend, I am Ajay Singh Rajendrakar. As we see the swap space management, which information told by my friend Ashutosh. So let's see example of that, the swap space management. That is, suppose we have program address management and RAM address management. In this example, we seems that the programs one by one comes to the program management, and it will pass to the RAM. It will until pass 0 to whatever memory, whatever 1 GB RAM, that is 1 GB RAM consider as a 1024. So after 1024, what happen? There is no space available, means our system get collapse. There is no space available here, that is pointed as a question mark. But by using swap space, that is a virtual memory, for example, we consider as a mapping. In mapping, suppose here is the program as counter as a 0 1 2 until the RAM is full, but after RAM is full, there is no space available. So what happen? But that this problem will be solved in virtual memory. The whatever processes has come in the memory will be stored in hard disk drive, the hard disk drive will be store means whatever inactive pages in a RAM will be stored in disk with the help of mapping. Whenever it's required, it will be again reactive and completion of that the process. Next, here we seems that the again whatever program is stored in 0, again it will be reactivate in RAM, and again process will be started as the program 3. Okay, then example. In this example, we have to calculate the swap. Means our RAM is 2 GB and system physical hard disk drive that is of 32 GB. We have to make a 2 GB. We have to make a swap memory. Means we have to make more memory, more RAM in the system, which is for efficient work, and more system will be full supported for the applications. Means if that is amount of RAM is GB and s swap amount of in GB. Suppose if less than equals to 2, it will be stored in suppose this condition will be true, is stored in the swap. But if
swap is equal to m,
swap is equals to m into 2, means our swap memory will be increases as far as, and if false, then it will be stored in swap. Means our suppose our system memory is 2 GB, then our swap memory will be 4 GB swap. Okay.
So multiple choice questions depend on our topic swap space management. There are 5 multiple choice questions given in this video. Virtual memory uses disk space as an extension of 4 options: secondary storage, main memory, tertiary memory, none of this. Using swap space significantly dash system performance, that increases, decreases, maintains, or does not affect. Linux does not allows or none of these use of multiple swap spaces, and single swap space dash reside in 2 places: can, cannot, must not, none of these. When a fixed amount of swap space is created during disk partitioning, more swap space can be added only by repartitioning of disk or adding another swap space elsewhere. 4 options for that: only first one is true, only second one is true, both are true, both are not true. So if you watch this video carefully, you can answer these questions. These are very simple questions, depend on our topic, in order to help you to how much you understand from this video. Some theory questions: is it possible to increase swap space partition? If yes, then how? Explain it. What is swap space partition? What is the recommended swap partition for 8 GB RAM? If you have watched the example in this video carefully, you can answer this question. And what is difference between swapping and paging? Here are some references which we use in this video for making this video. Hope you like this video. Thank you.